Welcome. My name is Ajay Devendran, and I'm a junior at Roxbury Latin. Today, I want to talk about a project that I started and created called LitterLens, which is an AI-powered drone system used to identify and locate plastic pollution before it enters water bodies. So before I start today, just by a show of hands, how many of you guys have used ChatGPT before? Okay, almost everybody. And how many of you think you're creative? Less, but almost everybody. Okay. So this number, 2,000, is a pretty staggering number. It's the amount of garbage trucks of plastic dumped into our oceans, rivers, and lakes every single day. But that's it, 2,000 a day. So plastic is a large problem. Today in my presentation, I'll start by talking about the problem, which will be plastic pollution. I'll then explain my drone project, how I built it, and how it works. And then I'd like to talk about the future of where technology can go in sustainability. So first, before I get into the data and anything else, I'd like to talk about my inspiration for this project and for climate change. So I lived in California for 2 years for my 5th and 6th grade, and in that time, I experienced multiple large wildfire events. One of them particularly was very close to my house. I vividly remember my dad grabbing just a few passports, my mom grabbing a few family photos, I grabbed a few clothes, and we got in the car. Since our phones weren't working, we didn't know where else to go, so we drove west towards the ocean, and it was a pretty scary experience. And as a result of that, I really felt the effects of climate change and how it felt real. It wasn't just a number anymore for me, and there was smoke in the area for a long time. I wasn't able to play baseball or flag football or anything else, which is something that I love doing. And at that point, I started thinking about what would happen to future generations who may be affected by these great effects and not being able to spend time outside and do the things they love. And the third thing was photography. I am very passionate about photographing wildlife, sports, and landscapes. It taught me to observe and document the natural world, which I think is very important, and that also inspired my use of a drone. A lot of my work can be found on Instagram at ARDFrames. A lot of people just imagine that plastic just ends up in the ocean somehow, and that's not really the case. 80% of ocean plastic starts on land and gets carried into the ocean by rivers. During heavy storms, that number increases tenfold as so much plastic gets funneled into our oceans via rivers. Researchers identified about 1,000 rivers, which are responsible for almost 80% of the plastic that ends up in our ocean. So that's a relatively small amount of rivers for the amount of plastic in the ocean. And the Charles River is a great example of an urban river that collects a lot of plastic and dumps that plastic into our oceans. So what happens once plastic actually enters our water bodies? Well, it has a large effect on animals and sea life, as I'm sure a lot of you have already studied. It goes up through the food chain, ends up in animals like crabs and mussels, and then travels up to the larger predators. Plastic bags have a large impact on a variety of sea life, and fish that are exposed to microplastics have a wide variety of health issues. And it doesn't only affect wildlife, it affects humans as well. It ends up in our food and in our bodies because humans consume a good amount of seafood. It also ends up in our water and affects water quality, which poses a severe amount of effects down the line. And we can really see that plastic in the water is an environmental issue, but it's also a public health issue. So now I'd like to get into my project, which is called LitterLens. It's an AI-powered drone system which detects and categorizes trash in an image and combines computer vision and drone technology. Essentially, it works in 3 steps: identify, locate, and inform. For the identification part, the drone can fly over an area, let's say a river, a park, or a field, and take pictures of the land below it. From there, it uses the GPS coordinates of the photos, puts those images into an AI system, which I coded and created, and can detect if there's trash in that image, and if so, what type of trash. Since this is just a prototype at this point, I've gotten the first 2 steps, and the next steps would be to use that data to inform cleanup teams on where to go to increase their efficiency as they pick up trash. So how I built it. Well, I'll be honest with you, I am not a computer scientist, and I really don't have too much experience with code. Last summer, I took a course called Using AI to Make AI at Brown, where I learned how to use ChatGPT to write the code behind an AI system. I used a pre-trained model called MobileNet V2, which essentially can understand basic shapes, textures, and images, and then from there, used about 17,000 images to refine it to be able to identify trash. A good analogy is reading. If our goal is to teach someone to understand Shakespeare, it's much easier to start with someone who already understands English than to start with someone who only understands Spanish. And so the images really refine the data, refine the AI system to be able to identify plastic, metal, and clothing, which would end up on our beaches and near our rivers. And I would be lying if I said ChatGPT solved all of my issues in one click. While ChatGPT is great, there was a handful of issues while I coded it. First was that the data set was too similar. Initially, I had used images of only trash on beaches, and because the sand was the background for all of the images, the AI system ended up memorizing instead of actually being able to identify trash in a variety of real-world scenarios. I was also training the AI system on a Mac, which is powerful but not super powerful compared to other AI computers, and so it was a little bit slow, and that influenced my use of a pre-trained model as opposed to starting from scratch. I had to rewrite the code multiple times. ChatGPT made a lot of mistakes, so I had to feed it its own error messages and do a lot of iterations, but it ended up working after quite a few weeks. And testing at the park. Some of you may remember over March break or winter break when I was working on this that there was about 2 feet of snow on the ground and the Charles River was completely frozen. So that influenced my testing at a local park as opposed to near a river where I wanted to test. So here's an example of it in action. Let's see. So you can see that I took images off of Google, put it into my AI system, and it was doing a pretty good job of being able to guess what it saw in the images, and worked decently well. And on the right side, you can see me testing it at the park with a bottle and the paper bag there, and it did a pretty good job of detecting that real-world image as cardboard, which is what that bag was made out of. In the future, I think drone technology has a wide application in Boston, but also globally. There's a variety of cleanup groups in the Boston area who are doing great work that I would love to partner with. There's a lot of research institutions who are already studying plastic in the Boston Harbor, Atlantic Ocean, and Charles River. And the third is municipalities and schools. I'm sure a lot of you guys, as part of an environmental group, have done cleanups. And imagine how much quicker and efficient it would be if you had a drone to tell you exactly where to go instead of trying to find the trash yourself. That's one thing that a drone could be super helpful with. Also, globally, drone and AI technology is relatively inexpensive compared to other ways of cleaning up. In areas like India and other Asian countries on the coast where there's a lot of plastic pollution, a drone could be a much needed intervention in order to find plastic and help those cleanup teams clean up a lot faster. And in terms of my project itself and my technology, I think there's definitely a lot of room for growth. One of them would be to expand its detection to be able to see more than just large objects like bottles and plastic. Second would be real-time GPS mapping. So right now, the images need to be sent to a computer before they can be put into the AI system, but being able to do that in real time would make the drone even more effective. Larger data sets would make the AI system more accurate, but that would require a stronger computer. And fourth would be partnerships. I think if we can partner with other groups in this area, the drone data can be actually put to use and plastic can start being picked up. So today, I want to leave you with something relatively simple. The technology we need is already here. Young people who are curious and can use the technology like we have, like almost all of you told me at the beginning, can do so much with the technology we have, like drones, AI, cameras, social media, and so much more. You don't need to be an engineer, you don't need to have a degree, you don't need to be a computer scientist in order to use the technology around you to do good. Protecting the natural world is something that our generation has a lot of responsibility for as we grow older and for our kids and generations after that. And so I hope today, throughout the rest of this conference, everybody in this room thinks about how to use your own skills and your creativity to create a more sustainable planet and use the technology we have for good. Thank you.